Hello guys, it is Research Series, and in this session I want to teach you how to normalize your dataset. But first of all, I want to review for you what is the normal distribution and why it is so important. As I mentioned previously, normal distribution lets the researcher to use the parametric tests which provide more information than the non-parametric tests which are used for a dataset without a normal distribution. For example, if you have a dataset that has normal distribution, you can use students or independent t-tests, but if the dataset lacks normal distribution, then you are forced to use man-Whitney U-test. So let's begin. I have a dataset here, the weight of the patients, and first of all I want to measure their distribution and see if they have a normal distribution or not. So I choose this option, Analyze, Descriptive Statistics, then Explore. You must enter this item weight to dependent list, and you must choose this icon, plots. You must choose histogram and normality plots with tests, and then continue and OK. You have a skewness amount here, 0.9, and if the skewness is between -1 to +1, it can be considered normal, and this value here is borderline. And you have Kolmogorov, Smirnov, and Shapirovic tests, which are usually reported in the articles as the proof of normal distribution. If they are less than 0.05, then it can be concluded that your dataset has not a normal distribution. As you can see here, they are less than 0.05, and my dataset lacks normal distribution based on Kolmogorov, Smirnov, and Shapirovic tests. And you can see a histogram here, which can visualize it better with clicking and choosing this item. As you can see, my histogram also shows that the dataset lacks the normal distribution, and it is not a symmetric bell-shaped histogram. And the HTML leaf chart also shows that my dataset lacks the normal distribution. Most of the numbers must be located here in the center, but they are here in the margin. Also, based off the QQ plot test, my dataset lacks the normal distribution. The dots here, and here are not located or near the line. They must be located or near the line to conclude that the dataset has a normal distribution. And also the box plot shows that the dataset has not a normal distribution. The median is not located in the middle of the box. This line shows the median, and the arms are not equal in size. So how can I normalize my dataset? Actually, there are several mathematical functions in the SPSS which can help you to normalize your dataset. But before that, you must know if you want to normalize your dataset and then measure, for example, weight with, for example, height of patients. You need to do the same as you are doing with the weight. I mean that whatever you are doing with the weight, you need to do the same with the other variable, for example, height or whatever it is, because you are using the mathematical function to change these values here, and if they are changed, you must do the change for the other variable, for example, height, age, or whatever it is. So let's begin. To use these functions, these mathematical functions, you must choose this option, transform, and then compute variable. So as I mentioned previously, you have several mathematical functions. You can choose this icon here, all, and a box will open here. One of the mathematical function is sqrt, and this mathematical function can calculate the second root of each value. I choose sqrt here, and then this icon, it appears here, and I send my variable weight into the mathematical function, and I name the new variable sqrt. And then OK. A new column just appears here as sqrt. It is the second root of these values. For example, the second root of 56 is 4.48, and then you need to measure the distribution of all of these variables. For example, if you produce a new variable as sqrt here, you must find out if it has a normal distribution or not. Using these mathematical functions does not guarantee that the function can produce always a normal distribution for you, and you must check it. So I go here, analyze, and descriptive statistics, explore, and I send back the weight and enter sqrt, and OK. So the skewness just decreased from 0.9 to 0.7, and we can see that the Kolmogorov, Smirnov, and Shapirov tests are not significant here. The value of significance, this number and this number are more than 0.05, and also my histogram improved in shape, and I can show that this line here is more closer to the horizon, and however, it is not indicating complete normal distribution, but it is closer to normal distribution. Also, my leaf and my stem and leaf chart has been closer to the center, and similarly these dots has been closer to this line. So as my Kolmogorov-Smirnov tests and skewness amount are showing that my dataset has nearly a normal distribution, I can use this new column and perform my comparisons by using parametric tests. But if I can form a better column with a better distribution of normality, I can use other mathematical functions. For example, I can also go to here, transform, compute variables, and I remove this one, and I can use ln. The ln is a logarithmic function of the SPSS. I put it here and then wait. Okay. Now, okay. A new column appeared here, and again I must measure the normality of my dataset, and I go here, descriptive statistics, explore, and sends back sqrt, and I put ln here, and okay. As you can see here, the skewness again decreased from 0.9 to 0.4, and the significant amount of Kolmogorov-Smirnov and Shapiro tests also became non-significant here, and notably my histogram improved in shape, and I can show you this line, this curve, which has been closer to the bell shape, and also the stem and leaf plot is very close to the normal distribution, and again these dots here has been closer to this line in QQ plot, and also you can see this arm has been closer in size. So I can use this column for my analysis, but if I want to use this column for analysis, I must also do the same for the other variable I'm measuring their associations. If you enjoyed this video, please don't forget to like, comment, and subscribe. See you soon.